In this video we are going to look at algebraic expressions, and before we get started I just want to remind you on how to do mathematics. So number and copy the examples, ask your teacher if there are any steps that you do not understand, number the questions, and unless you have the ability to get fit while watching someone else run, you must do the questions on your own before watching the answers. Mark your answers. If it is incorrect, write down the corrections. Make sure you understand where you went wrong, so this will enable you to do better the next time you attempt a similar sum. Now for an overview on this video, the first thing we're going to look at is polynomials, then addition, subtraction and multiplication of polynomials, then equivalent expressions, then finding the product of two binomials, more complex products, quotients, substitution, squares and cubes of monomials, squares, roots, and cube roots of monomials. Alright, so starting with polynomials, example 1.1 says how many terms are in the algebraic expression. Now, a term is separated by a plus and minus sign. So meaning, if I draw imaginary boundaries here over the plus and minus signs, then they separate the terms. So that means we've got one term, 2, 3, and 4. So these are then 4 terms. Now the only time when you have a plus and minus sign and you've got that in one term is, for example, if I've got, I was going to draw over or write it over here. If I have 2 plus x squared minus 3x, and I've got these in brackets, the brackets group the terms together. So in this case, we'll only have 2 terms. And another scenario is if I have, let's say the same thing, if I have 2 plus x squared minus 3x over 4, then this fraction also represents only one term. Alright, so for B, determine the numerical coefficient of x squared in this expression. Now, coefficient is the number that stands in front of the variable. So if I have x squared, my x squared lies over here. And the number that's in front of x squared is 1. If there's no number, it's always automatically 1. So my coefficient is this number over here. So the sign is very important. So my coefficient will then be minus 1. And as another example, my coefficient for xy is going to be minus 3, for x cubed is going to be plus 2, and so forth. Okay, now for question 1.1, examine the algebraic expression. List the numerical coefficients of x cubed, x squared, y cubed, z, and z squared. So for A, x cubed's coefficient, so that's over here, and the number in front of x cubed is 5. So that's going to be 5. Then for this term over here, we just have plus this term, so there's an imaginary 1. So that means it's 1. And then for z squared, over here it's negative 1. Then B, how many terms are there in the expression? So if we separate them with the plus and minus signs, then we have 1, 2, 3, 4 terms. So 4 terms. For C, write down the constant term in the expression. Now, a constant term is just simply the term that contains no variable, and a variable is a letter of the alphabet, and it's called a variable because it varies, it can change. Because if I put a 1 in place of x, and remember these variables, they represent numbers. So that means you can put a number in there and then it will change the value. So if I put 1 in here, we'll have 5. If I put 2 in here, this becomes 40. But this 13, no matter what I do with these x, y, and z's, this 13 always remains 13. And that's why it's called a constant, because it remains constant. And once again, when they say write down the constant, the sign is also very important because the value here is negative 13. So my constant is negative 13. Example 1.2. All right, now we need to simplify this expression. So what are we going to do? First, we're going to multiply out our brackets. All right, so if I multiply out my bracket, this, and always think about your terms separately. So remember, that's the dividers of the term. So this is one term. So this is the only term that we can actually multiply out at this point. So I'm going to say 2. Then to multiply it out, I take the negative 3 inside the bracket. So it becomes negative 3x, because minus 3 times x is negative 3x. Then minus and a minus gives me a plus. So this becomes plus 6, because we say 3 times 2. And then I have my minus x minus 2. Right, so now once all our brackets are gone, we can now add the like terms. So the like terms are the terms that contain x. Those are like terms. And then we have these constant terms, and we can add them. Okay, so minus 3 minus x. So this is the same as minus 3 minus 1. So if I have if I'm in the negative 3 and I go further back into the negative 1, then I go to negative 4x. Okay, and then the constants are 2 plus 6 is 8. Minus 2 is 6 again, so this is plus 6. Now this is where I end, because I cannot add minus 4x plus 6, because I cannot add this x to a constant. So this is my final answer then. Question 1.2. Okay, so now in this case we don't have any brackets that we need to multiply out, so I can just go ahead and add my like terms. Now what I always do is I just identify which ones are like terms. This one and this one. So this is x squared. So everybody that contains an x squared, I underline, for example, and then everybody that contains a x, I circle, and then everybody that's constant, for example, I draw a square. You can maybe use your highlighters and highlight them different colors, because you see there's so many terms we have to take into account. So now if you know, okay, let's first deal with the stripes, then I know, okay, it's just that one and that one. So then I don't have to, each time I have to add something, go and search through everything. Now I can go directly to my stripes, and I say 2 plus 2 is 4x squared. Then my terms that only contain x, so 3x minus 5x. If I have 3 and I take away 5, I go into the negative 2, so that's minus 2x. And then my constants, plus 5, take away 3, or 5 minus 3 is plus 2. B, now before I can add my terms, I've got brackets here. So the first thing I need to do is get rid of my brackets. So these terms I can just copy. So that's 5y plus 6 plus 8x. Now what is a plus times by a minus? A plus and a minus gives me a minus. And the way to remember this is a plus and a minus are different. So it's going to be a different sign. Then a minus and a plus also different, so different. So a minus and a minus are the same, so they make a positive, and a plus is the same, so it makes a positive. So plus and minus gives me a minus 2y. Then a minus and a minus, they're the same, so they give me a plus x. All right, so now let's add the like terms. We've got x, we've got y, and we've got one constant. Let's start with x as our stripes, our y's as our circles, and then we have this one constant over here. So 8x plus x gives me 9x. 5y minus 2y is 3y. And then we just have that plus 6 that's on its own, so we can just write that there. And this is where we leave our answer. We can't add these. So now for C, I've also got brackets here. And to multiply them out, I have to take this 3 into the brackets, but this 3 needs to go to all the terms inside the brackets. So we have 2, which we write, plus 3. Now, this is also a common error. Some people would add this. That's very wrong, because remember, these are separate terms. So that means this 3 is stuck to this bracket over here. So before you can do anything with this 3 has to go inside first. And then you can simplify it after the brackets is gone. Okay, so that is then 3x and then plus 3 minus x. Okay, my like terms is 3x minus x. That gives me 2x. 2 plus 3 is 5, so that's plus 5. Example 1.2, so arrange the following polynomial in descending powers of x. Now, what does descending mean? Descend means I am going down. So that means I start, if I'm descending, I'm going down. It means I'm starting with the highest value going to the lowest value. Now, powers of x, we've got x squared, we've got x to the power of 1, and we've got x to the power of 4. So which one is the highest? This x to the power of 4 has the highest exponent. So this term will then become the first term. But now remember your signs, the sign in front of the term belongs to the term. So this sign needs to travel with it everywhere like a tail. So this is then going to be minus 2x to the power of 4y. And then for the x to the power of 2 plus x squared y to the power of 4, and then plus x y to the power of 3. So normally in maths, or the correct mathematical way to do it, is to always write your terms in descending powers of the applicable variable. Question 1.3. So all of these we just basically need to write in descending powers of x. Okay, so in this one we have x to the power of 6 first, and then x to the power of 5, and then minus 5 x to the power of 4, then plus 3 x to the power of 3, and there is no x to the power of 2, then there's plus 7x and minus 4. Then b, so this one goes first, minus 5x squared plus x plus 8. C, we have x to the power of 3, so that's 9x to the power of 3y, plus x squared y, and then plus xy cubed. Then D, the biggest one is this x to the power of 5 plus 3x to the power of 3 minus 4x squared. Okay, so that was the polynomials. Let's look at the addition, subtraction, and multiplication. So this example says add the following polynomials. Now, there's two ways to do it. The one way is to simply add them, like put them in brackets and add them. The other way is to add them in rows, like putting them underneath each other. Now, in this example, I'm going to do both methods, but when I answer the questions, I'm just going to do the first method where you just simply add them, because I personally believe it's the easiest. When you add them underneath each other, especially actually when you begin to subtract them, it becomes quite difficult, or it can become complicated, but that depends on you. So you choose which method you like. All right, so for adding the polynomials, we have to add this to this and this. So I just simply say, okay, x squared minus 2x plus 4 plus this one minus 2x plus 5 plus this minus 3x squared plus 7x. Okay, so those are my expressions that I'm adding. So now let's just get rid of the brackets. Now, these brackets, this plus sign, if I multiply in a plus sign, the signs just stay the same. So this is just basically going to be x squared minus 2x plus 4 minus 2x plus 5 minus 3x squared plus 7x. Okay. Now I've got x squareds, x's, and constants. So my x squareds are there. My x's are here, here, and here. And my constants are here and here. Right, so x squared, we've got x squared minus 3x squared, that gives me negative 2x squared. Then I have my x's is minus 2, minus another 2 is minus 4, plus 7 gives me plus 3x. My constants are 4 plus 5, which is 9. Okay, and that's my final answer. Now, if I should do it using or adding them underneath each other, I would say x squared minus 2x plus 4. Then I would put this one underneath here. So that's going to be, but now when I put it underneath here, I have to list my like variables underneath each other. So this minus 2x belongs to the center row where or column where I go minus 2x plus 5. And then this one is minus 3x squared plus 7x. And then I just add them. So this is actually also quite organized. It's also not a bad method actually. So 4 plus 5 is 9. Then minus 2 minus another 2 is 4 plus 7 is 3x. This is plus 9. That's plus 3x. And then x squared minus 3x squared is negative 2x squared. Add the following polynomials. Alright, so I think I'm going to do A with the one method and B with the second method. Okay, so we've got 2x squared minus 5x plus x squared plus 4, and then plus 7x or negative 7x plus 8. Okay, so this is 2x squared minus 5x plus x squared plus 4 minus 7x plus 8. And then this, and this is x squared. These are my x terms, and then this is my constants. Okay, so 2x squared plus x is 3x squared. Then minus 5 minus 7 is negative 12x. And 4 plus 8 is plus 12. Okay, so that was A. Then B, I'm going to list them underneath each other. So a squared minus 4a, then minus a minus 5, and then 2a plus 7. Okay, now we add. So this is just a squared. Minus 4 minus 1 gives me minus 5, plus 2 gives me minus 3a, and then minus 5 plus 7, or if I can say plus 7 minus 5, that's easier, that's plus 2. Okay, so once again, question 2.1, we have C. So here I'm going to say the one method where I use minus 2b plus 5 plus b squared plus b plus 4, and then plus 2b squared plus 2b minus 8. Okay, let's just rewrite that. Minus 2b plus 5 plus b squared plus b plus 4 plus 2b squared plus 2b minus 8. Okay, then squared squareds, and then b, and constant, constant, constant. So my square is 1b plus 2b, that's 3b squared. Then minus 2b plus b gives me minus 1, plus 2b gives me 1b again. So what would actually be easier is if I just look at this one. I see this is minus 2b, that's plus 2b. So these two can just, they become 0, and then I'm just left with this plus b. And then constants, we've got 5 plus 4 is 9, minus 8 is 1. For D, listing them underneath each other, p squared minus 8p minus 1, and then 2p squared minus 4p minus 2, and then minus 3p squared minus 10p plus 3. Okay, so p squared plus 2p is 3p squared minus 3p squared, so that's 0. Minus 8 minus 4 is minus 12. Minus another 10 is minus 22p. And then minus 1 minus 2 is minus 3. And then plus 3 is 0. So this is my answer, minus 22p. Okay, so now we get to subtraction. So the subtraction is actually where the first method is more practical. And you'll see now. So if I say subtract this expression from this expression, it means I take this expression and I subtract this expression from it. So I take this expression, say 2x squared plus 5x minus 12, and I subtract from it x squared minus 5x plus 3. So now we just simply multiply in the minus and we add our like terms. So this is 2x squared plus 5x minus 12 minus x squared plus 5x minus 3. And then my like terms, so 2x squared minus x is x squared. 5x plus 5x is 10x. Minus 12 minus 3 is negative 15. Okay, so the second method is, once again, we say subtract this from this. So taking this one, the second one, we've got 2x squared plus 5x minus 12. And then subtract x squared minus 5x plus 3. Now this is where it gets kind of confusing, because you're subtracting this, you need to multiply in this minus here, so you have to change each and every one sign. Now if you're doing this, I'd recommend that you put your signs in a different color on top of this. So if this was a plus, this becomes a minus, this now becomes a plus, and this becomes a minus. So now we do our calculation. So 2x squared minus x squared is x squared. 5x plus 5x is 10x. And then minus 12 minus another 3 is minus 15. All right, so there's the two methods. You pick the one that you feel more comfortable with. Okay, so for question 2.2, subtract this expression from this expression. So I say 2a squared minus a minus 3, and then I subtract from it a squared minus 4a plus 2. Very important that you put your brackets. Then we have 2a squared minus a minus 3. So this becomes, when I take it to each and every term, I just simply change my signs. That becomes minus a squared plus 4a minus 2. So adding this and this, and then these two terms, and then those two terms. 2a squared minus a is a squared. Minus a plus 4 is plus 3a. Minus 3 minus 2 is minus 5. For B, from this, subtract this. So from that guy, take away that. So that's 5x squared minus 3x plus 7. Then we subtract 2x squared minus 6x minus 4. So let's multiply out the bracket. We just copy this over. So it's minus 2x squared. This becomes a plus. That becomes a plus. Our like terms. Okay. 5x squared minus 2x squared, that's 3x squared. minus 3x plus 6x gives me plus 6x, plus 3x, sorry. 7 plus 4 is 11. Okay, so C, from this, subtract that. So first we write minus 2b squared minus 3. From that, we subtract minus b squared minus 5. So multiply out. So minus and a minus becomes a plus, and minus and a minus becomes a plus, and then our like terms, minus 2b plus b is minus b squared, minus 3 plus 5 gives me plus 2, positive 2. D, subtract this guy from this guy. So taking this guy first, 5p cubed minus 9p plus 7, and subtract 2p3 minus 4p plus 3 from it. So let's multiply outer brackets, 5p cubed minus 9p plus 7, so minus 2p cubed plus 4p minus 3. Alright, so these are our like terms. I've got 5p cubed minus 2, that's 3p cubed. Then minus 9 plus 4 gives me minus 5p. 7 minus 3 is plus 4. Okay. Now simplify this expression. Alright, so here we are just given these variables or terms again. And here we need to just multiply out our brackets and then add our like terms. So with this, there's nothing in front of this bracket. So these brackets, well, an imaginary 1, yes, which if you multiply in this, everything stays the same. So let's just drop those brackets. So we've got 5p squared minus 6p plus 2. And then I multiply in this minus 2. So now if I take a number inside the brackets, normally we just had our negative with the previous examples. But if I take a number in, this number needs to be multiplied to the coefficient of every term. Okay, so this is then, and remember, be careful when you have a minus, so you have to multiply the 2 and you have to change the sign. So this becomes minus 12p squared minus 10p and minus 6. So once again, we have our like terms. Okay, 5p squared minus 12p squared gives me negative 7p squared. Negative 6p minus another 10 gives me negative 16p. Plus 2 minus 6 is negative 4. Question A. So there's nothing in front of these brackets, we can drop those, but there's a negative in front of these. So to multiply out, we have y squared plus 2y plus 3y squared minus y squared plus 4y. And then like terms, alright, y squared plus 3y squared is 4, minus 1 gives me 3 again. So this is 3y squared. 2y plus 4y is 6y. And then we're done. B, now here's nothing in front of this one, or just imaginary 1. Here we have a minus that we need to take in. And here we have just plus, but if I multiply the plus 1, it's also just going to stay basically the same. So we have 3p squared minus 3p minus 5. Then we multiply the minus by changing the signs, minus 2p squared plus 2p plus 5. And that just stays minus p squared minus 2p. Okay, so now we have our like terms, and here, and then here. Alright, and there's our constants. Okay, now, so 3 minus 2 is 1, and then minus another 1 is 0. So that's, these guys add up to 0. I don't have to write that down. Then minus 3p plus 2p gives me minus 1, minus another 2 gives me negative 3p. Or as we saw previously, plus 2 minus 2 is 0, so there's this negative 3p left. Then my constants is minus 5 plus 5, which also adds up to 0, so this is then just my final answer. Okay, so C. Right, so I'm going to do these a bit faster just so that you have the answer. Otherwise, you can just skip to the answer and mark your work. I assume you've done it. So then 3x squared minus 5xy plus y squared, multiplying in the minus, that becomes plus 3x squared plus xy plus 2y squared. Okay, there's y squared as like terms. Then we have this x squared here and here, and then we have xy here and here. Okay, so this is then 3 plus 3 is 6x squared. Then minus 5 plus 1 is minus 4xy, and then y plus 1y plus 2y squared is equal to plus 3y squared. D. Okay, so here we multiply out the negative, and then there is just a plus 1. So this now becomes, so see, this separates these terms. So this 1 is on its own over there. And then we have negative 3x squared y plus or minus 2xy squared plus xy. Then that becomes plus, or stays, plus 4xy minus x squared y plus 2. Okay, right. Now, like terms. So here I see this one and this one are like terms. And then this guy is on its own. This is the only one that has x, y squared as a like term. Then we have this xy as like terms. And then we have our constants. So let's start with the stripes. Minus 3 minus another 1 gives me minus 4x squared y. This loner over here is just minus 2xy squared. Then these ones are, they become plus 5xy, and then that's 1 plus 2, so that becomes plus 3. Okay, so now multiplying out these brackets, those have to be multiplied, and that guy has to be multiplied. This can just be dropped, that can just be dropped. So that's just a minus 3b minus b plus a plus 5b minus 3a plus 5a. So a, the rest are b's. So 1 plus 1 is 2, minus 3 is minus 1. So 2 minus 3 is minus 1, plus 5 is plus 4. So this is 4a, and then for the b's, minus 3 minus another 1 is minus 4, plus 5 is 1. So this is then plus b. Okay, so that was addition, subtraction, and multiplication. Now let's look at the equivalent expressions. So now we just have to simplify this, and here we just have to multiply in, once again, multiply out of brackets, except now here we have a variable in front of our bracket. So we're going to treat this variable exactly like the coefficients, where we just multiply it into each and every term. And if I have x times by x, then it becomes x squared. So here we have 2x squared minus 3x. So that's that simple, and once again these aren't like terms, so that's where I leave my answer. Okay, now we multiply in this. So here we just have an example where we have both a constant or coefficient and a variable that we multiply in, and a negative sign. So the first thing you need to do is to, when we multiply it in, think about your sign. The sign changes. So this, for this first one, it becomes a minus. Then you multiply your coefficient. So 2 times 1 is 2. And then your variable. So a times a squared is a to the power of 3, because I add my exponents. Next, we go to the second term. So a minus and a plus is a minus. And then 2 times 3 is 6. And a times a is a squared. Next, the last term, minus and a minus is a plus. 2 times 4 is 8. And a times by, well, that just stays 8. Okay, now we have two sets of brackets. So this guy goes into these brackets because it only applies to the one that it stands next to, and this one goes into those. So this is then 2x squared minus 6 multiplied with a 3 plus 2x squared plus 14x. My like terms are these, and these two are both on their own. Okay, so 2x squared plus 2x squared gives me 4x squared, and then plus 14x minus 6. Okay, so now we are here. So be careful for these kind of sums, because mostly you'd tend to do this calculation first, where you'd say 5x minus 2x. But remember, always look out for your separate terms. This term belongs to itself and that term. So first you have to multiply these out, and then you can go on and add the like term. So we're going to put the 2 into the bracket. So this is then 5x. Now this becomes minus 2x squared minus 6x. And then my like terms are this one, which is minus 2x squared. 5x minus 6x gives me negative x. Okay, so for question 3.1, we multiply out this bracket. So for A, we have 3x squared minus 15x. For B, we don't have anything in front of this bracket, so we can basically drop those brackets. So it's x minus 2 minus 3x. So my like terms are these two, which then becomes 1 minus 3, which gives me negative 2x minus 2. Then for C, if I multiply this one in, I get 3p to the power 3. Then here I have 3 times 2, so that gives me negative 6p squared. And then 3p times 1 minus 1 gives me minus 3p. And then D, so this guy needs to go into this bracket, and this one needs to go into this bracket. So this becomes, if I multiply it with the first term, it becomes negative 2y squared, then negative 4y, then plus y squared, then minus y. Like terms, these and then these. So this is then minus 2y squared plus y is minus y squared. Minus 4 minus another 1 is minus 5y. Okay, multiplying these out. So once again, if you feel okay with the work, still do these sums, but if you're confident with your work, just go and mark your work. If you still struggled with the previous ones, then look through the way that I explained them. Okay, so this is then going to be multiplying with the first term and then the second term. This gives me, for E, minus 2b squared plus 20b, and then going over to this one times by that is minus b squared plus 3b, and then that's plus 3b squared. Okay, so that and that and that. So this is then minus 2 minus 1 is minus 3, plus 3, that gives me 0. So they add up to 0. And then for the terms that contain b only is 20b plus 3b is 23b. And then f. Okay, so we multiply this one out and this one out. So we have 7b to the power 3 minus 14b squared minus 7b. Then multiplying this in, we get negative 3b to the power of 3 plus 12b squared. My like terms are these guys, and then to the power of 2, and then there's just one of those. Okay, so 7b cubed minus 3 is 4b cubed. Minus 14 plus 12 gives me a negative 2b squared, and then minus 7b. And then finally for g, we multiply this out. This term is already just on its own. This 5 needs to go in, and that 12's there on its own. So this is then 3x minus 6 minus 2x plus 5x minus 15 plus 12. Okay, like terms. We've got x here, here, and here, and then the rest are constants. So 3x minus 2 is 1, and then plus 5 gives me 6x, and then minus 6 minus another 15, that gives me negative 21. So negative 21 plus 12. If I say 21 minus 12, if I take the difference between them, that guy has to borrow 1. So this is 1, 11, this is 9. Alright, so it's 9. So between, where am I now? Negative 21, so minus 21 plus 12. I found the difference, so then it's equal to 9. And then the one with the biggest one, you take his sign. So the biggest one is 21, so it gets a negative. So this is then minus 9. Okay, now example 3.5. This one it looks similar to the previous ones we've done, except that this coefficient is now here. Now that's not, that's actually just the same thing. If I say x times y, it's exactly the same as saying y times x. So if I say this value times by this one, it's basically the same thing as saying 2x plus 7 times by x plus 7. So what I'd recommend is that you'd always, if there's a number here, always just put it in front and then multiply it out from the left side. It's just easier if you're used to that. Okay, so this then becomes 2x squared minus 6x plus 2x squared plus 14x. Okay, here are my like terms. So this is 4x squared minus 6 plus 14. It's easier to say plus 14 minus 6. And that is equal to 8x plus 8x. Okay, now once again we've got this minus x over here, so I'm going to rewrite this as minus x minus 2. Okay, so then I just multiply and minus x. So this is then 3x squared plus 2x minus x squared plus 2x. Here are my like terms. They are 3 minus 1, so that's 2x squared, and then 2x plus 2x is 4x. Okay, now also be careful here. Remember the previous one had brackets. This one doesn't have brackets. That means that this is actually a term on its own, where these two are now separated. So the only thing that gets multiplied in is the one that's right next to the brackets. So this is then minus 3x squared minus 2x. There's just a 1 in front of this bracket, so that just stays plus x minus 2 minus x. Alright, so what are our like terms? This one is minus 3x squared, which is on its own. then we've got this, this, and this. So plus x minus x equals to 0. So I'm just left with minus 2x. And then we have this constant over here, which is minus 2. Okay, so for A, now we see this one lies on this side of the bracket, so I'm going to rearrange it and say just 3y, y squared minus 2y minus 3, and then multiply it in. Then it becomes 3y cubed minus 6y squared minus 9y. And that's it. Then B. So I'm going to take, you see there's now a 2 on this side of the brackets and there's a y on this side. So I'm just going to take my y and I'm going to put it in there to say 2y, y plus 3 minus y, y minus 4. Okay, so then it's just more comfortable to multiply it in there where you, if you don't do that, you have to kind of take the 2 from here and the y from there, and then it just becomes a mess. So here we have 2y squared plus 6y, and then minus y squared plus 4y. Okay, and then these guys get added. 2y minus y is y squared, and then 6 plus 4 is plus 10y. See? Now, once again, this one might look like it's multiplied, but remember, this is these terms are separated. So this is on its own, this on its own, and this one. So now we have a negative in front of this bracket, which we multiply in. We have 2a minus 3 minus a. Then my like terms are these. So 2a minus a is 1a, minus another a is 0. And then I'm left with this negative 3. Okay, D. Right, multiply these guys in, multiply. So, okay, before I do that, let's put the a in front of the bracket. So I have a plus 2 minus a 2a plus 1. So I multiply in the a, I get a squared plus 2a minus 2a squared minus a. Right, these are my like terms, so that becomes negative a squared plus a. E. Right, this b, I want to put it in front. I'm just going to write it there now, otherwise I have to rewrite these twice. So this minus goes in, so this is minus ab plus b, then plus a squared b, then minus ac squared minus a squared b minus bc squared. Okay. Right. Now this one is a bit more complicated to look for like terms. Here we have a plus a squared b and a minus a squared b. So I'm just going to cancel these two. Then there's only this one minus a b. There's only one that says plus b. Okay, so the rest are all on their own. And then that means that's our final answer there. Okay, right, so this guy belongs to this term. So multiplying that in, so let's just rewrite that then. Minus 2x minus 3y minus 2x, x plus y, and minus 2xy. Okay, so we have one term, three terms. Multiplied in, negative 4x squared plus 6xy. Then going over to the second term, minus 2x squared minus 2xy minus 2xy. Okay, then my like terms are these, and the rest are the xy terms. So this is minus 6x squared. Then this is 6 minus 2 minus 2, so it's the same as 6 minus 4, which is plus 2xy. Okay, now simplifying this one is a bit more complicated, and we've got quite a few brackets here, but now always work from the inside, okay? Now, unfortunately, we have to, when you do your steps, you have to put the whole thing in each and every step, okay? So the first thing I'm going to start with is the most inside. See, this guy is the most inside of all of these brackets. Then we have these and the square brackets. So to get rid of this brackets that are on the most inside, I have to multiply this minus 2 in there, okay? So I have to repeat all of this. Okay, and then here I'm going to multiply in the minus 2, which gives me minus 2a plus 2 plus a square brackets. Okay, so that was our first step. Now we add the like terms, because now we can simplify this inside. See, now this funny brackets are our most inside bracket. So now we just simplify that. So once again, do the whole rhyme. 3 minus, so a minus 2a is minus a plus 2 plus a, all right? And now we can get rid of these funny brackets by multiplying in this minus into them. And once again, everything else needs to come along. We have 3 over here. This minus goes in, it becomes plus a minus 2 plus a. Okay, now we can add the like terms inside this bracket. A plus a is 2a, and 3 minus 2 is 1. And then finally, we multiply our final bracket, and we get 8a squared plus 4a. Okay, so here are 2 for you to do. Right, so if I look at this one, my bracket that is on the most inside is this guy over here. All right, so I'm going to start by multiplying that one out. Right, let's write this down. So we have 5a, so 3a minus 4 funny bracket a, so that becomes minus 2a minus 10. And then we've gotten rid of our round brackets. This is also something we can do so long, but let's do that with the, let's wait before we do that. 2a plus 3 square bracket. Okay, so if you look closely here, look at what's happening here. We've got this square brackets over here, and then inside the square brackets we've got this set of brackets and this set of brackets. So we can now in this step multiply this bracket out, and we can multiply this minus out. Still put our 5a minus. Okay, so this is then 3a, this becomes minus 4a plus 8a plus 40 minus 2a minus 3. And then inside here we can add our like terms. So all my a's are basically these ones and that one. So 3 minus 4 is minus 1, plus 8 is plus 7, minus 2 is plus 5. And then 40 minus 3 gives me 37. Okay. Now in front of this bracket we have a negative which we take in, and this gives me 5a minus 5a minus 37. And my final answer, 5a minus 5a is 0. My final answer is just negative 37. Alright, moving on. Let's look at this. We have these funny brackets over here. So this one is the most inside, where we start by multiplying this out. Okay, so you have x minus 2x minus 5. So minus, there's an x over there, minus 3x plus 3. Okay, and then I'm just going to rewrite this minus 4 minus x minus 2. Okay, so inside here we've got two brackets. we multiply this one out and we multiply this one out. X minus, so 2x minus 5x plus 15x. Oh, we should have actually first added this, but that's fine. We'll add the like terms now. Minus 15. Then plus 4x plus 8. Okay, so let's add our like terms. We have an x here, 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 here. So 2 minus 5 is minus 3. Plus 15 is 12. And then plus 4 is 16. So this is 16x. Minus 15 plus 8 is negative 7. And then we multiply in this minus. We have x minus 16x plus 7. And then we get negative 15x plus 7. Right, so that was equivalent expressions. Let's look at finding the product of two binomials. Now, for the first example, example 4.1, when we multiply our two binomials, and a binomial means it's a expression with two terms, then what we need to use is FOIL. So you can look at this in one of two ways. With FOIL, we say this is first, so then you multiply the first two with each other. Then outer, so then you multiply the outer two with each other. Then inner, you multiply the inner two with each other. And last, you multiply the last ones with each other. Now, another way that you can look at it is you focus on the first term in the first bracket and you multiply it with both. And then you focus on the second term in the first bracket and you multiply it with both in the second bracket. So either way you want to think about it. So when we multiply it out, we say x times x is x squared. Then x times negative 3 is negative 3x. Then minus 5 times x is minus 5x. Then minus 5 times minus 3 is plus 15. Alright, and then once we've done that, we can just look out for any like terms. We see minus 3x minus 5. Those two are like terms. So minus 3 minus 5 gives me negative 8x plus 15. Okay, so let's look at this one. So I'm going to focus on this first one, then multiply it with both in the second bracket. So I have 2x times 3x is 6x squared. Then 2x times negative 4 is negative 8x. And then I focus on the second one and I multiply it with both in those brackets. The second bracket, minus 3 times 3 is minus 9x. And then minus 3 times minus 4 is positive 12. Adding like terms, we've got these two middle terms. So that's going to be negative 8 minus 9 gives me negative 17x plus 12. Okay, so A is going to be multiplying these two will be x squared plus 3x, and then multiplying these two is minus 5x minus 15. Then just simplifying it, I have x squared minus 2x minus 15. For B, multiplying out that, we have 2x squared plus x, then minus 10x minus 5. That's now multiplying out those two. And then we have 2x squared. Adding these like terms, I get negative 9x minus 5. Then C, 2x times 5x gives me 10x squared plus 8x. Then for the 1 becomes minus 5x minus 4. And then 10x squared plus 3x minus 4. D, I start by multiplying out the first term. We get 15x minus 12. And then these two is 5 plus 5x squared minus 4x. So now we can just put it in standard form where we list it from the highest degree in descending order. So we've got 5x squared, and then we can add our like terms. We've got 15x minus 4x, so that gives me plus 11x, and then minus 12. Okay, so for D, I get 4x squared minus 2xy. Then for y multiplying both, we get negative 2xy plus y squared. Just simplifying this, we've got 4x squared minus 4xy, because this is minus 2 minus another 2, plus y squared. For E, I have y squared plus 3xy minus 2xy minus 6x squared. And then to simplify it, we add the like terms, y squared plus xy minus 6x squared. For F, multiply out, that's 21 for this times this, then this one times that one will be negative 9x. Then these two is plus 14x, and then these two are minus 6x squared. Then we have, if I put it in standard form, and remember the sign goes with the term, so this is negative 6x squared. Add my like terms, 14 minus 9 gives me plus 5x plus 21. And then G, so now I just need to multiply out fractions. So with this one, this is just x times x, so that's x squared. But then this one times by this one is minus x over 4. You can either write x over 4, or you can write 1 over 4x. Both of those mean the same thing. And then if we move over to the half, we multiply that one and that one. So this is going to be plus x over 2. And then multiplying these two together, we have a plus times a minus is a minus. And then when we multiply fractions, we just multiply the numerators together. 1 times 1 is 1, and the denominators 2 times 4 is 8. Okay, so these two are like terms. It's easier actually to see if you write it as 1 over 2x. See, both of these are just the coefficients. So these are like terms because they both have just x as their variable. So we have x squared. Now, if I say minus 1 over 4 plus 1 over 2. So if I say minus 1 over 4 plus 1 over 2, if I want to add these fractions, the denominators needs to be the same. So this one I'm going to change to 4. This is then minus 1 over 4 plus 2 over 4. So minus 1 plus 2 over 4 gives me 1 over 4, positive 1 over 4. So this becomes plus 1 over 4, or I can say x over 4, because 1 over 4x is the same as x over 4. Okay, and then minus 1 over 8. Now we have this bracket squared. Now the first thing that I see a lot of people do that you can't do is simply to take this 2 into both, and then you say it's equal to x squared minus 25. So this is wrong. Okay, so you cannot do that. What you need to do is first to expand it. Now there's actually two ways to do this. There's a short way and a long way. I'm just going to do the way that I see most of you guys prefer to do, by expanding it, because if I have x squared, it's the same as saying it's x times x, right? So if I have this bracket squared, it's the same as saying multiply the bracket with itself twice. And then we just FOIL it out. So then it's just like we've done now previously. We say this one times this one is x squared. Then this one times that one is minus 5x. Then we move over to the second one. That's minus 5x. And then the last one plus 25. So this is then x squared. Then minus 5 minus another 5 gives me negative 10x. And then plus 25. Now the other way that's shorter is, okay, so I'm just going to rewrite this here, x minus 5 squared. The steps are as follows. For the first term, I square this first term inside the bracket, so that's just x squared. The second term, I take this term, multiply by that term, which gives me minus 5, and then I just multiply it by 2. That gives me minus 10, so this is minus 10x, and then I square the last term, which is always a positive, so that's plus 25. So recap, square the first term, multiply them together, multiply by 2, and square the last term. So you can use any method you like. For the sake of writing the answers, I'm going to use the short method to save time. Okay, so here we have this example, right? So this example I'm still going to do in both methods. The first method, expanding 6x plus 3, I write it out twice, 6x plus 3, and then multiplying the first term out, so we have 36x squared, and then plus 6 times 3 is 18, plus 18x, and then here 6 times 3 is 18, so plus 18x, and then 3 times 3 is 9, so that's plus 9. And then simplifying, I just have 36x squared plus, so 18 plus 18 also gives me 36, so this is then 36x plus 9. Alright, so now the shorter method is to square the first term, and that's 36x squared. Then if I multiply, 6 times 3 is 18, times by 2 is 36, so this gives me plus 36x, and then square the last one, which is plus 9. Right, so for A, I've got x squared, squared the first one, multiply together is 1x, times by 2 is 2x, so plus 2x, and then square the last one, so that's plus 1. For B, square the first one is p squared, multiply together is pq, times by 2 is plus 2pq, and square the last one is q squared. And C, square the first one, you get 4x squared, times by each other is 2x, or negative 2x, times by 2 is negative 4x, and then square the last one is plus 1. Okay, so that was then finding the product of two binomials. Let's look at a few more complex products. Now in this case, this is what we've just been doing, squaring that. So now we just see here's a 2 in front. So what I'm going to do is I'm first going to square this out. So, but then the 2 still needs to be there. So I'm going to just keep the 2 there. And then when I square this out, the answer will be x squared plus 6x plus 9. And then once I've done that, I can bring in the 2. So I cannot take in the 2 first before this square isn't gone, because that wouldn't be mathematically correct. So now I can say 2x squared plus 12x plus 18. Okay, here we have just two binomials, but we have a negative in front of it. So if, I'm first going to multiply out my two binomials, and then I'm going to, at the end, multiply in the minus. So I have to put a minus with a bracket in order to, at the end, multiply the minus in. So x times x is x squared. X times plus 7 is plus 7x. Minus 5 times by x is negative 5x. And then minus 5 plus 7 is negative 35. Now just to put the minus in, or actually before we do that, let's just add our like terms. X squared, 7 minus 5 is 2x minus 35. And then I multiply in my negative by just changing all the signs. So we've got negative x squared minus 2x plus 35. Okay, so here we also have these two to multiply out first, and then after we've done that, we multiply in the 3. So the 3 has to be there, just hanging around until we've completed this calculation. So we have 2 times 2, or 2x times 2x is 4x squared. Then 2x times minus 5 is negative 10x. And then 5 times 2x is plus 10x. And then minus 5 times by positive 5 is negative 25. Alright, so like terms, we've got this 4x squared here. Minus 10 plus 10 adds up to 0. And then we write the negative 25. And now we can multiply in the 3. So this gives me 12x squared minus 75. Okay, so now squaring first and then multiplying the negative. So this is going to be square the first term. That gives me x squared. Multiply with each other. If I multiply these two terms with each other, and then multiply with 2, oops, this is a 3, I get 2x over 3. So then it's negative 2x over 3, and then square the last one would be plus 1 over 9. And then I multiply my negative in, so this is minus x squared plus 2x over 3 minus 1 over 9. Right, so for A, we have the 2, and then simplifying this, I get x squared minus 2x plus 1, and then I multiply the 2 in, I get 2x squared minus 4x plus 2. For B, I multiply these guys out first, but the minus 2 needs to be there, so we've got x squared minus 4x plus 8x minus 32, and then we can just add those like terms, minus 2, so x squared minus 4 plus 8 gives me plus 4x, or I can think about it 8 minus 4 minus 32, and then we multiply in the negative 2, so we get negative 2x squared minus 8x plus, because a negative and a negative is a plus, plus 64. For C, I'm going to simplify that first. I've got squaring the first, so that's 4x squared. Then multiply together is 10x. Multiply by 2 is 20x. And then square the last one plus 25. Multiply in the negative, so minus 4x squared plus 20x minus 25. Right, so we're going to start with this. We have negative a squared, b squared. So that's 3a squared. Then we've got plus ab. Then we get negative 9ab. And then finally we have negative 3b squared. Right, so this is minus a squared, b squared. Then we can add these like terms, so 3a squared, 1 minus 9 gives me negative 8ab minus 3b squared, and then multiplying in with the first term, so we've got this negative, minus and a plus and negative, we've got 3 as our coefficient, and then our variables, we've got a to the power of 2, and here we've got a to the power of 2, so that becomes a to the power of 4 and b squared. Now moving on to the next term, we've got a negative times a negative, that's a plus. 1 times 8 is 8. A squared times a to the power of 1 is a to the power of 3. B squared times b is b to the power of 3. Moving on to the last term, a minus and a minus is a plus. 1 times 3 is 3. Then a squared. And then b squared times b squared is b to the power of 4. So this was D. Now for E, so I'm going to do this once again. I've got negative xy squared. Then in brackets, I have 6x squared. Then plus 10xy. And then minus 3xy. And then minus 5y squared. Right, these are my like terms. So 6x squared, 10 minus 3 is just 7xy minus 5y squared. And then multiplying it with the first term, a negative and a positive is a negative. Then 1 times 6 is 6. x to the power of 1 times x squared is x to the power of 3, and we've got the y squared. Negative and a positive is a negative. 1 times 7 is 7. X times x is x squared. Y to the power of 2 times y to the power of 1 is y to the power of 3. Final term, minus and a minus is a plus. 1 times 5 is 5. We've got this x and then y to the power of 4. Right. So here we have example 5.5. So this is going to be kind of a long sum. We have to remember what I said. If you see a complex sum, just break it up into its different terms, simplify the terms, and then add your answer. So this is a term, and that's a term. So we know how to simplify this term. We know how to simplify that term. So let's just start off by doing that. So we have x squared minus 2x plus 3x minus 6. So I just multiplied, out like we've been doing. And then plus, now here we have x squared plus 4x. That's the first one multiplied out. And then negative 7x minus 28. All right, so now let's look at or identify our like terms once again. That's my x squared. And then I have the terms that contain x, and then I have my constant terms. Okay, x squared plus x squared is 2x squared, minus 2 plus 3 gives me 1, plus 4 is 5, minus 7 is negative 2x, and then minus 6 minus 28 gives me negative 34, and then we're done. Okay, and now for this one, here we just have a square, and there we have these brackets again. Now, what's important? Okay, so I'm just going to simplify this, then I'll tell you what's important about this negative. So this is a squared, multiply with each other, multiply with 2, gives me 5a times by 2 is 10a plus 10a, and then square the last one is plus 25. Now, because of this negative, when I multiply these out, I have to put brackets because this negative is going to apply to everybody inside the bracket. So now going ahead with our normal procedure, a times a is a squared, minus 3a, minus 4a, plus 12. Okay, so now the first thing I need to do now before I can do anything else is to multiply in the negative in order to get rid of the brackets. So a squared plus 10a plus 25. So minus a squared plus 3a plus 4a minus 12. So signs just change when I multiply in the negative. Okay, so like terms, we've got this one and this one. And then the terms that contain a on its own, or a, are these. And then my constant terms are these. All right, so a squared minus a squared, that adds up to 0. Then I have 10a plus 3a is 13a plus 4a is 17a. Then 25 minus 12 is 13. So this is plus 13. So that's our final answer there. All right, now let's look at this one. Same story. This one is just quite long, where we have 3 terms. So this is going to be 4x squared. Multiply together is 6x, multiplied by 2 is negative 12x. Square the last one is plus 9. Then minus with my brackets. This is 9x plus 3x plus 3x plus 1. Then x squared, this is 9x squared. X squared plus 2x minus 4x minus 8. Then let's multiply out those brackets. So 4x squared minus 12x plus 9. I'm going to actually do this in one step. I'm going to add these like terms and multiply my brackets out. So this minus goes in. This becomes minus 9x squared. This is 6x, but when I multiply in the minus, it becomes minus 6x minus 1. and then minus x squared. This becomes minus 2. So 2 minus 4 is minus 2. When I multiply it with a minus, it becomes plus 2x plus 8. So there's my squares. So I've got 4x squared minus 9x squared gives me negative 5, minus another one is negative 6x squared. Then this one, and this one. So minus 12 minus 6 is minus 18, plus 2 again gives me minus 16x. And then finally we have plus 9, minus 1 is 8, plus another 8 is plus 16. Alright, so here we have this one. Now what makes this one a bit more complicated is that we have both these squares and we have a coefficient in front there. Okay, so 2, and then multiplying this one out is x squared plus, multiply together and with 2 is plus 10x plus 25 when I square that one. Then minus 3. Then multiplying this one out is x squared minus 3x minus 4x plus 12. And then that one is x squared minus or plus x minus 1. Okay, so now let's multiply the brackets out. So this is 2x squared plus 20x plus 50. Okay, this becomes negative 3x squared. So these two terms, these like terms, become negative 7. Minus 3 minus 4 is negative 7. If I multiply negative 7 with negative 3, I get plus 21x. And then 12 times by 3 is negative 36. Then minus 4x squared. So plus x minus x is 0. Then minus 4 times minus 1 is plus 4. Okay, like terms. This one, and this one. So 2 minus 3 is minus 1. Minus another 4 is minus 5x. Then over here, I've got 20 plus 21 is 41. So plus 41x. And then my constants 50 minus 36 plus 4. So 50 minus 30 is 20, minus another 6 gives me 14. 14 plus 4 is 18. Okay, A. So multiplying these out, I get 4x squared minus 10x plus 25. And then I have my minus 4x there. So inside the brackets, actually this I can multiply out immediately. So this then becomes, I'm just going to scratch that, minus 4x squared when I multiply it with the first term, plus 20x. Now, like terms 4x squared, these two, minus 10 plus 20 or 20 minus 10 gives me plus 10x. We also have this one that contains x, so that's minus 4. So this is going to give me 6x and then plus 25. For B, we have this that we first have to multiply out, and this one, keeping it in brackets because of this negative over here. So I have 2, then x squared minus 2xp plus p squared. So then minus x squared minus 3xp minus 2xp plus 6x or 6p squared. Okay, then multiplying out, we have 2x squared minus 4xp plus 2p squared with a negative minus x squared. These two are like terms, so minus 3 minus 2 is minus 5. Multiply minus 5 with a negative gives me plus 5xp minus 6p squared. So these are like terms, which is 2 minus 1 is just x squared. Then I've got xp over here and over here. So this is minus 4 plus 5, which gives me plus 1. So that's plus xp. And then these two is 2 minus 6 is negative 4b squared. For c, multiplying that out, we have 9x squared plus 3x minus 3x minus 1. And then when we multiply this one out, we just put the x also here. So we remove it here, so we can just multiply it in from the left-hand side. So this becomes negative x squared plus 4x. And then squaring this out, we have plus 9x squared. Multiply together is 6. Multiply with 2 is negative 12x. And then plus 4. So like terms are these. And these are the ones that contain x. And then we have the constants. So 9 minus 1 plus 9. So 9 plus 9 is 18. Minus 1 is 17x squared. Plus 3 minus 3 is 0. So 4 minus 12 gives me negative 8x. And then my constants is minus 1 plus 4 gives me plus 3. Then for D, so first thing we're going to multiply these out. And we can also actually multiply these out. But here we first have to simplify that. So this is going to give me 2x to the power 3 plus 10x squared. Then multiplying that out is negative 3x to the power 3 plus 6x squared. And then plus 15x. Alright. Then what we do now is to say plus x. Now I'm just going to write this here underneath. So this has to go right here. Then we have x squared minus 3x minus x plus 3. All right. So let's actually just write this x here with this one. Okay. Now for the next step, I'm just going to start adding like terms here while I multiply this one out. So here we've got these two, and we have these two that are like terms so far. So just to make this sum shorter, we've got 2x to the power of 3 minus 3x to the power of 3. That gives me negative x to the power of 3. 10 plus 6 is plus 16x squared. And then we have that plus 15x. Okay. And then multiplying this one out, I've got plus x to the power of 3. Minus 3 minus 1 is minus 4. And then multiply with x is minus 4x squared. And then plus 3x. So now adding the remainder of the like terms, minus x to the power 3 plus x to the power 3, they add up to 0. Then 16x squared minus 4x squared is 12x squared. Then 15 plus 3 gives me plus 18x. For E, so this one is actually quite simple. The first thing I need to do is just to first square this bracket. I've got 5x to the power 3 minus 4x, which still just hangs around there. Then we've got x squared, multiply with each other, multiply by 2 is minus 4x, and then plus 4 plus 10x squared. And then we multiply out this bracket, got 5x to the power 3, so minus 4x to the power 3 plus 16x squared minus 16x plus 10x squared. My like terms are these two. So that's going to be just x to the power 3 then the squares are this one and this one. So that's 16 plus 10. That gives me plus 26x squared minus 16x. Right, so that was the more complex problems. Let's look at a few quotients. Okay, so for example 6.1, now quotients are exactly like fractions. And what we're going to do is now to simplify this fraction. So we know that to simplify this, I want to see what factor can go into 12 and 30. What is the biggest factor that can divide into both of them? So if I have 6 can go into 12 and 30. So I just say divide by 6, top and bottom, because what I do at the top I have to do at the bottom for it to be equivalent fractions. So 12 divided by 6 is 2, and then 30 divided by 6 is 5. Now, if I don't see 6 immediately, for example, I can say 3 can go into both of them. So if I say 12 over 30, and I say, okay, divide by 3 top and bottom, then I have 4 over 10. And then I can see it's still not in its simplest form because both of them are even. So that means that 2 can go into both of them. So that's divided by 2 top and bottom. And that gives me 4 divided by 2 is 2 over 5. So you see in both cases we get to the final answer. So you don't have to immediately get the biggest one. You can take it in smaller steps. Alright, so now we have this one, and this 5 over 10, we're just going to treat like the previous example, and we can see that 5 can go into itself and in 10, but instead of writing divide by 5, I'm just going to say 5 can go into itself once and into 10 2 times. Alright, and write it as small numbers. Now I can cancel top and bottom with my variables. I can see there's a b in the top and b at the bottom, so I can cancel these two. And then I just write what's left. So at the top we only have an a, and in the denominator we have 2c. Then that's my final answer. Right, and now 6.3. So here we have x, y, and z as our variables, and they have exponents. So there's two ways to do this. Now, once again, we treat this 12 over 18 as we've been doing. 4 can go into 8 2 times, and into 12 3 times. Now, we've been doing this in fractions and in exponents. So if I use my methods which were taught in fractions, if I have x squared over 3, x squared over x to the power 3, this is the same as x times by x over x times x times x. So I can cancel 1 at the top with 1 at the bottom, 1 at the top with 1 at the bottom. So what I basically have left is just 1 over x. Or if I want to do this with my exponent laws, I can say, because these are the same bases that's divided, I subtract my exponents. I have x2 minus 3, which gives me x to the power of negative 1. And if I have a negative exponent, I take my base down and I have 1 over x. So both of these result in the same answer, but this one is faster. This is easier. And even because we don't expand it like this, you have to say, or have to think about it in a way that x squared is just 2 x's next to each other, similarly x to the power 3. So the easiest way to do this, or the fastest actually, is to say 2 of these x's I cancel with 2 at the bottom, so I just have 1 there. Then if we move over to y, there's 2 y's here, the denominator, and then I cancel them with 2 at the top, so I just have y, 1 of the y's left, and then the z, 2 at the bottom cancels with 2 at the top, so I have 2 left. And then I just write what's left. So in the numerator I've got 3yz squared. In the denominator I just have, or I have 2x. Okay, but you can use these exponential laws if you prefer to use that. Okay, so question 6.1 for A, 12 and 16, what can go into 12 is 4. 4 goes in there 3 times and in there 4 times. Then this x cancels with 1 at the top, and then this y cancels with 1 at the top, which is 2. So what is left? We've got 4xy squared over 3. For B, 9 goes into itself once, into 18 2 times. 2 e's cancel here with 1 at the top. These f's cancel. 1g cancels with 1 at the top. So what is left? We've got 2eg over 1, which is just basically 2eg. And then C, 11 goes into itself once, into 22 2 times. 2 of these x's cancel with 2 at the bottom. 3 of these y's cancel with 3, so we're left with 2. Now we have 2 at the numerator. In the denominator, I've got xy squared left. And then for D, so before I am going to start cancelling, I think I'm going to just start by multiplying out this. Let's just simplify that. So 3 times 2 is 6, a times a is a to the power 3, and b squared times b is b to the power 3. And that's over 12ab to the power 3. So now, if I cancel, 6 goes into itself once, into 12 2 times. These two cancel each other, and I'm left with 1a here cancels with 1 at the top, so that's a 2. Alright, so now we have an a squared in the numerator and a 2 left in the denominator. Now just something that is useful. As you can see here, when we cancelled with a different color, it's kind of more clear of what is left. So, and this looks a bit more like a mess. So just a tip, if you do these cancellations, do it with a different color so that you can identify what's going on there more easily. Right, now these examples contain quotients that have more than one term in the numerator. So how we go about to solve these, if I'm just going to show you a simpler example. So if I have a over b over c, or a plus b over c, I can break this up into a over c plus b over c, because remember, if we have the same denominator, we can add the numerators, which just brings us back to that. So if I have more terms here, I can break it up again into 5x over 5x plus 10x, or 10 over 5x, and then I can independently simplify my fraction. So 5 and 5 will cancel, and x will cancel. Now that doesn't mean that's 0. This is then, remember there's a 1 left here, 1, so that's 1 over 1, which is just 1. Then plus 5 goes into itself once, and into 10 2 times, so that's just plus 2 over x. So this is then our final answer. Right, so example 6.5, we do the same. We have 2x to the power 3, y to the power 3 over 4x to the power 3, y to the power 3, minus 2x squared, y to the power 4 over 4x to the power 3, y to the power 3. Alright, so now just to cancel, 2 can go into itself once and into 4 2 times. These guys cancel each other, those two cancel. We're left with a half, minus 1 goes into itself, 2 goes into itself once, into 4 twice. 2 of these cancel with 2 at the bottom, so there's 1 left. And then 3, y to the power 3 cancels with 3 at the top, meaning there's 1 left. So now I have y in my numerator. Denominator, I have 2x left. Example 6.6. Here we just have 3 terms, so breaking that up, I've got 3a squared b cubed over negative 3abc minus minus 6ab squared c squared over negative 3abc plus 4 a squared b squared c squared over negative 3abc. Okay, So signs, this one is just negative. These 3's cancel. A cancels with 1 at the top. B cancels with 1 at the top. There's 2 left. So I'm going to rewrite this immediately. I'm not just going to cancel everything. I'm going to rewrite this while I'm working with this. So this is going to be AB squared over C. Now signs, moving on to the next one, a negative and a negative over here becomes positive. Then 3 goes into itself once, into 6 2 times. These A's cancel. B cancels with 1 at the top. C cancels with 1 at the top. And I am left with plus 2 and then BC, because everybody in the denominator was cancelled. And then the last one, a plus and a minus, is a minus. 4 and 3 can't cancel, so then the A cancels with 1 at the top, B with 1 at the top, and C with 1 at the top. So I have 4 ABC over 3. Okay, so for question A, breaking that up, I've got 2x squared y to the power 3 over 8xy minus 4xy over 8xy. So 2 goes into itself once, into 8 4 times. This x cancels with 1 at the top, y cancels with 1 at the top, leaves us with 2, or y squared. So this is then x y squared over 4, and then negative. Then 4 goes into itself once, into 8 2 times. These guys cancel, those guys cancel, and I'm left with negative a half. Then for B, 5a over 5a plus a squared over 5a. When I break it up, then those cancel with those, so that's just 1, plus this a cancels with 1 at the top, and I'm just left with the a, so that's a over 5. Alright, so now we have 9abc over negative 6abc squared, and then minus, so this is this minus, 12ab squared over negative 6abc squared. So cancelling, we've got a negative there for the signs. Then 3 goes into 6 2 times, and into 9 3 times. These a's cancel, b's cancel, 1 of the c cancels with 1 of the c. So what's left here is 3. What's left here is 2c. Minus and minus gives me a plus. 6 goes into itself once, into 12 2 times. A's cancel. 1 of the b cancel, 1 of that b's. So what we have left here is 2b over c squared. So this was C. Now for D, I've got 16a squared b squared C over 4a cubed b cubed C plus 8ab cubed c squared over 4a cubed b cubed C minus 4a cubed b cubed C over 4a cubed b cubed c. Okay, 4 goes into itself once, into 16 4 times. Then 2 a's cancel with 2 at the bottom, 2 b's cancel with 2 at the bottom, and the c's cancel. So for the first term, I've got a 4 in the numerator, and then I have in the denominator an a and a b. Plus 4 goes into itself once, into 8 2 times. Then 1a cancels with 1a, so there's a squared left. These b to the power 3, b to the power 3, and then the c cancels with 1 at the top. So this is then 2c over a squared. And then here we have 4's cancelling, a to the power 3, b to the power 3, and c. So I have minus 1 left. Okay, so that was quotients. Moving on to substitution. So example 1 says determine the value of negative x plus 8. So we need to find out what this value is. if we're given that x is minus 4, so this is my expression, and remember what a variable is. A variable is a letter from the alphabet, but it represents a number, all right? And now we're actually given the value of that number. So basically what you need to do is, now if I have minus x plus 8, I need to replace my x with my number. And whenever I replace it, you have to replace it in brackets, because that makes your calculations more accurate. So if I say minus, then wherever I see x, I just put my brackets with my value inside of it, given that it's negative 4 plus 8. And now I'm just going to simplify this. So minus and minus is a plus 4 plus 8, and then I get 12. Okay, so let's look at this example. It says x squared plus 3x. So x squared plus 3x, and I'm given that x is a half. So wherever I see x, I'm going to replace it with a half inside brackets, plus 3 half. Right, so now I've got, remember how I treat this square, I take it to all my bases, so this becomes 1 over 4. And when I multiply these out, 3 is the same as 3 over 1, right? So if I have 3 over 1 times by 1 over 2, I get 3 over 2. So this is plus 3 over 2. And when I add my fractions, I have to get the same denominator, multiply top and bottom with 2. So I get 1 over 4 plus 6 over 4. And that gives me 7 over 4. So I'm just going to leave my answer like that. Okay, 7.3. So my expression, minus 2x squared, and my value is a half. So this then becomes minus 2 in brackets a half squared. Now, important, we have to simplify this part first before we can multiply with the negative. So this then becomes, so I'm just going to say equal, this becomes minus 2 times by times by 1 over 4, because the square went to all top and bottom. And then if I have minus 2 over 1 times by 4, so I can cancel, I can say 2 can go into itself once and into 4 2 times. Then I have a negative. 1 times 1 is 1, and 1 times 2 is 2. Question 7.1. So we need to evaluate this. And for A, if I have 2x minus 5, and my value for x is 3, then replacing 3 here, minus 5. So to work this one out, 2 times 3 is 6 minus 5, and 6 minus 5 is 1. For B, x is equal to 0. So if I have 2x minus 5, and my x is 0 minus 5, then 2 times 0 is 0, minus 5 is just minus 5. Okay, so evaluate this one if x is negative 2. So we're going to substitute in my negative 2 here and here. Now I have minus 2, then negative 2 squared, minus 4, negative 2 plus 8. Now see what happens if I don't use brackets. If I say negative 2 squared, my answer, and you can test it with the calculator, this becomes square, this becomes 4, so it's negative 4. But if I do use brackets as I should, remember a negative number squared becomes a positive number, so it's plus 4. So here it is extremely important to use brackets. So let's simplify this. We've got this that we need to simplify first, so that becomes 4. So this is minus 2 times by 4. Minus, now this is a minus times a minus, so this becomes a plus 8. And then we have that plus 8 over there. Now this is minus 8 plus 8 plus 8. So minus 8 plus 8 is 0, plus another 8 is just 8. Okay, so substitute in We'll substitute x equals to 2 and y equals to 3 into the expressions below and then simplify. So now we have two variables and we're given their values. Now for the first one, for a, we've got x squared plus xy plus y. So my value for x is 2. So wherever I see x, I say 2 squared plus 2 times y, which is 3 plus 3. Okay, so this is then 4 plus 2 times 3 is 6 plus 3. So this is 10 plus 3, which gives me 13. For b, I have x plus y squared. So x is 2, y is 3. So 2 plus 3 is 5 squared, which is 25. C, we have negative 2x squared plus xy plus y squared. So negative 2, instead of x I say 2 and then squared plus 2, and y is 3, and then plus 3 squared. So negative 2 times 4, then 2 times 3 is 6, so plus 6, and then 3 squared is 9, so this is 9. And then negative 8 plus 6 plus 9 is, so negative 8 plus 6 is negative 2. So I'm going to say, so I'm just going to start from left to right, simplifying this. This is negative 2. So negative 2 plus 9, negative 2 plus 9 is 7. Okay, so substitution is done. Let's move on to squares and cubes. Okay, now this we've done in exponents, and this just overflows with algebra as well. So what we do with this square is we have to multiply it inside the bracket, but what our law says of exponent is if I have a to the power of x to the power of y, what do? I multiply my exponent, so this becomes x times power y. Alright, so now taking the 2 in, it has to go to all the bases, so this just simply becomes 4 squared, and then a 3 times by 2. Okay, this is then 4 squared is 16, and a 3 times by 2 is 6. For this one, once again, this base, this is now cube, goes to each and every one. So we have 2 cubed x 2 times 3 y to the power of 3. Simplifying that, 2 to the power of 3 is 2 times 2 times 2, which gives me 8. Y, x to the power of 6 and y to the power of 3. Now for this one, if we have a coefficient over here, the first thing we need to do is just to simplify this part first, because this 3 is just an outsider for now. This square first has to go in before we can do anything with the 3. So the 3 just hangs around until we're done with the brackets. So putting the square at each base, we've got x squared, y. So 3 times 2 is 6, and z, 4 times 2 is 8. And then I can simplify. Now this 3 is multiplied, and this is just one term, all right? So that 3 is just gets, or the answer is just 3x squared, y 6, and z 8. If we had, for example, x plus y with the 3 here, then we had more than one terms. Then this 3 has to get multiplied to both of those terms, and then it becomes 3x plus 3y. But since this is one term, the 3 you don't multiply it with each and every one, you just multiply it with this one term once. Right, so taking in the 3 here, now what happens with a negative number when it's cubed? If I square a negative number, as we saw, it becomes a positive number, because minus times minus is positive. But when I have minus 1 cubed, I have a minus 1 times minus 1 times minus 1. So this and this becomes plus 1 times minus 1, but then plus times minus, that then just gives me a negative again, negative 1. So whenever I cube a negative number, it basically stays negative. So this is then a negative. Then 2 to the power of 3 then a 2 times 3 is 6, and b to the power of 3. So then just for the last step, we have that negative. This becomes 8, a to the power of 6, b to the power of 3. Right, so for a, the first thing we need to do is to multiply the cube in. So this x just hangs around there. So this becomes 2 times 3 is 6, so x to the power of 6, y to the power of 3. Now to multiply in the x, when we multiply the same basis, the exponents add. And if it doesn't have an exponent, it's automatically to the power of 1. So if I add these, 1 plus 6 gives me 7, and then y to the power of 3. Once again, that x just gets multiplied in. This is just one term, so it's only in once. All right, so b, so this 2 just simply goes to each base. So I have 3 squared, then x 2 times 2 is 4, y 3 times 2 is 6. So this becomes 9, x to the power of 4, y to the power of 6. Then for c, now there's no exponent over here. So basically I can just go ahead and multiply this expression with this one. So this is the same as if there were brackets here, or it's the same as saying 2a times 3a squared b. That's all the same thing. So 2 times 3, if I start with the coefficients, is 6. Then a times a squared, if this is to the power of 1, it becomes a to the power of 3. And then we have that b over there, and that's our answer. Okay, starting with this. So we have m to the power of 2 here. Then this 3 goes in. We have m 2 times 3 is 6. N 3 times 3 is 9. Then multiplying the same basis, we have m to the power of 8 when I add my exponents, and n to the power of 9. That was d. And then for e, first we take the 3 in, so minus 3x, then that's x to the power of 3, y to the power of 3, z to the power of 3. And then we have negative 3, x to the power of 4, y to the power of 3, z to the power of 3. For f, now before I multiply these two together, I have to take this 3 inside the brackets to each and every base. And remember, cubing a number stays negative, or cubing a negative number stays negative. So this is minus, then 2 to the power of 3 we saw was 8. And then we have a cubed, b cubed, c cubed. Okay, so let's keep that in brackets. Then we have 2 abc, and multiplying. Now we've got 3 things we need to multiply. We've got the sign, the coefficient, and the variable. Let's start with the sign. A minus and a plus is minus. Then the coefficients, 8 times 2 is 16. And then my variables, which means if I multiply the same base, my exponents add. So if this is to the power of 1, then this is a to the power of 4, b to the power of 4, c to the power of 4. Okay, so that was squares and cubes. And then finally, roots. Okay, now when I take the square root of a base with an exponent, what happens to take it out? I have to divide the exponent simply with 2. Now, I can, so if I have xy, square root of that, that's the same as saying square root of x times by the square root of y. So I can, if I want to, just first, break these up. But I'm not going to normally do that because I can just simplify this by taking it out and subtract, or taking the base out and dividing the exponent with 2. So dividing this exponent with 2 gets me to 1, so that's just x. Or whenever you have a x or a square here with a square root, these two are opposite operations, so they cancel each other out. And then y, divide that by 2 gives me 2. 6 divided that by 2 gives me 3. Okay, for this one, now 2 ways once again to, if I have square root of 64. Now the one way, if you know your roots, or like 1 squared, 2 squared, 3 squared, 4 squared, and so on. This is 1, 4, 9, and 16. If you know these off by heart, you'd immediately know that. So, for example, the square root of 16 again is going to be 4. So 64 is 8 squared. 8 squared is 64. So that means the square root of 64 is 8. So that's a one way. Or you can first take 64 and change it into 8 squared, which you then work with exponents, where I say I half my exponent. So this is just going to be become 8 if I cancel these, or I think about it as 2 divided by 2. Okay, so this is then going to be 8 when this comes out, x to the power of 2 and y. Okay, now we have a cube root. So when we had a square root, we divide our exponents with 2. Now when we have a cube root, we're simply going to divide our exponents with 3. And the general law for that is if I have a to the power of x with a root, a y root, then whatever the root is, I can divide it with, I just divide that with the exponent. So it's going to be a to the power of x divided by y. All right. Now this 64, so once again we have 1, 2, 3, 4, then cubed, 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 and so on. This is just 1, that's 8, that's 27, and that's 64. So if you know these numbers off by heart, you can simply take this number out and you know it is 4. Otherwise, you can first say the cube root of 4 cubed, a cubed, b 9, c 6, and then use your exponent laws even for your number. Divide 3 by 3, you get 1. So that's 4 to the power of 1, which is just 4. 3 divided by 3 is 1, so that's a. Then b, 9 divided by 3 is 2. C, that's 3. And then c, 6 divided by 3 is 2. And there we have our answer. Okay, now for this example, once again, it's just going to be square root of 3. So this is 4 cubed x to the power of 12. So divide 3 by 3, get 1. So that's just 4. 12 divided by 3 is 4. Okay, so 144. See, this is a square root. So 144 is 12 times 12. So if I take that one out, it's just 12. Then a to the power of 4, remember we divide by 2 now, so that's just a squared. B comes out. And that's our answer. Okay, so now 196, that's not a perfect square. So what we do with that is we have to let's first break this up into its prime factors, and let's use the ladder method. So if I have 196, my prime factors are 2, 3, 5. So whenever we have a big number and we're working with exponents, like I said in the exponents video, you just break it up into its prime factors, and then you work with your basis with the exponential laws. Now 2, can 2 go into 196? It can, because it ends with a 6, which is an even number. So if I just do my division here, 196, 2 goes in there, 2 can't go into 1, 2 goes into 19, 9 times, and then there's 1 left, 2 goes into 16 8 times. So this is then 2 goes in there 98 times. And then 2 can go into 98. So if we use 98, let's just write it here. And 2 goes in there. 2 goes into 9 4 times. There's 1 left. 2 goes into 18 9 times. So that's 49. 2 goes into 98 49 times. 2 can't go into 49 because it is a uneven number. But 3 can't go into 49, 5 can't go into 49, but 7 can. 7 goes into 49 7 times, and then 7 goes into itself once. Okay, so if I write this as prime factors, I write it as 2 squared times 7 squared a to the power of 6. Then if I take it out, because this is a square, it can come out of the square root, so this is just 2 times 7, and then a to the power of 3 when I divide that exponent with 2. So just to simplify our answer, we've got 2 times 7, and that gives us 14a to the power of 3. Okay, so question 9.1 for A, this is a cube root. So this, if I rewrite this, I get 2 cubed, x cubed, y to the power of 12, and then dividing all my exponents, I get 2x y to the power of 4. For B, 121 is 11 squared, so b to the power of 4, q to the power of 2, so 11 comes out of the square root. P to the power of 2, q comes out. C, 27 is 3 cubed, so x cubed, y power of 6, z 27. So this is the cube root, and this is then just 3. That's just x, that's y squared, and that's z to the power of 9. And then D, so 216. 216, let's do prime factorization with that. So 2 can go in there, 108, sorry, 2 comes here, 2 goes in there, 108. If I divide 200 with 2, I get 100, 16 with 2 is 8, so I add them. So 2 can go into 108, 54 times, 2 goes into 54, 27 times, then 2 can't go into 27, we move over to 3, 3 goes into 27 9 times, 3 goes into 9 3 times, 3 goes into itself once. So to rewrite 216, we write it as 2 to the power of 3, there's 3 2s, so 2 to the power of 3, times by 3 to the power of 3. And then we have d to the power of 9, e to the power of 9, and f to the power of 9. So this then becomes 2 times 3, d to the power of 3, e to the power of 3, f to the power of 3. This is if I divide all my exponents with 3. Just to simplify this, we then have 2 times 3, which is 6, d to the power of 3, e to the power of 3, and f to the power of 3. Okay, so now that was the final subsection, so that means we are finished.